Hi, in this video, we're going to look at the formula for area of a regular polygon. Area equals 1/2 the apothem times the perimeter. And just figure out, where does this formula come from? How does this formula work? Why does it work for every polygon that is regular? Remember, a regular polygon means all of my sides have the exact same length and all of my angles have the exact same measure. So just so that I have an example to work with, I have put a regular polygon here, a regular pentagon. Okay, so all 5 sides are the same, all 5 angles are the same. If I wanted to find the area of this and I didn't have the formula, let's think about what we would do. Okay, the first thing I would do is I would say, I know the area of a triangle equals 1/2 the base times the height. Okay, and we've talked about in our notes that the distance from the center of the regular polygon to the side of the regular polygon is my apothem, that little a. Okay, if I draw in what's called the radius of each one of these from the center of my polygon to 2 of the corners that surround that apothem, I'm going to create a little isosceles triangle here where the apothem is the height. Okay, and then this whole length down here is the base of that triangle. Okay, so I'm going to rewrite this formula as the area of this triangle, this one blue triangle that I have here, is 1/2 of this base times this height, and that height is the apothem. Okay, so I've got 1/2 the base times the height gives me this one blue triangle. Okay, now in this regular polygon, think about how many of those triangles I have. I could draw another one of those triangles here and have a second one, right? Here's a second triangle. I could have another one of those triangles if I draw up to the top. Here's another identical triangle. It's going to have the same 2 sides and the same base. It's just kind of rotated around. And then I could have another one if I draw out to here. Here's another triangle. And then lastly, I would have one last triangle right here. Okay, so I have how many triangles? I have a blue, an orange, a green, a pink, and a purple, and they're all exactly the same size because they have the same base and they're all the same distance. They all have that same apothem as their distance. And in this case, because I have 1, 2, 3, 4, 5 sides, there are 5 of them, right? So my area for this pentagon, the area for the pentagon, let me get a different color, is going to be 5 times the 1/2 the base times the apothem. Okay, so I end up with 5 times 1/2 the base times the apothem, and that works for the pentagon. But we are talking about not a pentagon. We're talking about, but what is going to work for every single polygon? What's the area for every regular polygon, not just a regular pentagon, right? So what would change in this formula for a polygon? Okay, let's think about it. So in a polygon, in any polygon, I'm going to have a different number of sides because I could be an equilateral triangle, and then I would only have 3 of these triangles. I could be a square, and then I'd have 4 of these triangles. If I was a hexagon, I'd have 6 of those triangles. If I was a stop sign, I would have 8, right? So this number here is going to change based on the number of sides. Okay, so the number of sides is going to affect this, how many triangles I can make. Okay, so instead of putting a 5 there, if I were to replace that with n for the number of sides, we could say the number of sides is going to give me the number of triangles I can create. I'm going to multiply that by 1/2, which is being multiplied by the base, which is being multiplied by the apothem, which was the height of that original triangle. Okay, so now we're close. We have 1/2 and we have an A, but how do my N and my B go away, and where do I get a P from? Well, think about the perimeter of a polygon, right? If I come over to the side and I think about the perimeter of a polygon, it's going to be adding all the sides together, okay? Well, however many sides I have, right? In this case, I have 5. I would multiply the side 5 times to get that, right? I would do 5. So for my pentagon, I would do 5 times the B, right? 5 times however long this base is, because all 5 of those sides would be the same. But if I'm doing the perimeter for any regular polygon, instead of a 5, I might have 6 sides or 7 sides or 8 sides. Remember, we're using N for the number of sides. So N times B is the same as the perimeter of the polygon. So my area of my regular polygon, remember, multiplication is commutative, which means we can do it in different orders. So I can rewrite this as, I can put that 1/2 in front. I can multiply that first, and then I can multiply by that A, and then I can multiply by the N, and then I can multiply by the B, and N times B is P. So look what happens when I substitute in for the N times the B. My area of the regular polygon becomes 1/2 times the apothem times the N times B, which is the perimeter. My area of the regular polygon is 1/2 the apothem, which is the height of the one triangle, times the perimeter, which is all those bases added together. And that ends up calculating all the areas at one time of all the triangles in your regular polygon. Okay, kind of a neat little formula. Thanks for watching.